Morning, dear students. Welcome to yet another session of HERON's formula. Today will be the last session of HERON's formula. I have to discuss a very important topic today, that is how to find the area of a trapezium using HERON's formula. It's a very important topic and a 4-marker question always being asked in the examination. So you have to pay really attention to it. You have to practice this type of questions. So let us see how it works. Otherwise, whatever we have done in the earlier classes, first of all we have seen that Heron's formula is used to find the area of a triangle, and we can use Heron's formula to find the area of a equilateral triangle also, and we have further seen how to find the area of a quadrilateral also. So area of equilateral triangle, if you remember, it is root 3 by 4 a square, where a is the side of the equilateral triangle. And how do we find the area of a quadrilateral? We divide it into two triangles and then find their areas and then add the areas. A quadrilateral which has one pair of opposite sides parallel is called a trapezium. So you have to be carefully listening the statement again. A quadrilateral which has only one pair of opposite sides as parallel, the other side is not parallel, is called as a trapezium. So we are having already a formula to find the area of a trapezium. So this question might occur to you that why we are using Heron's formula. So the reason is very simple, because in this trapezium, if the height is not given, then we will use the Heron's formula. So otherwise, if height is given, we can simply use the formula as half the sum of parallel sides into the distance between them, that is the height. But if height is not given, then we will use Heron's formula. Simple example I have taken just to revise the concept, that if the parallel sides are 2 cm and 10 cm and the height is given as 6 cm, what will be the area of this trapezium? So it is half into a plus b. A and b are the parallel sides. 2 plus 10 is 12 and multiplied by 6. So area will be 36 cm square. Now we will see the questions of today's topic where the height is not given. So we have to find the area for trapezium when the height is not given. So we'll be using Heron's formula. So the question says find the area of a trapezium whose parallel sides are 25 cm and 13 cm and the other two sides are 15 cm and 15 cm. So all the four sides of a trapezium are given, but height is not given. So we cannot apply the formula half into sum of parallel sides into height. So we have to devise a new method using Heron's formula. So this question, it is very important in order to know first of all. So ABCD is a given trapezium in which AB is given as 25 cm, CD is given as 13 cm, and BC is given as 15 cm, AD is given as 15 cm. So in this, what we do is we draw a line which is parallel to AD, that is CE. So draw CE parallel to AD. It is very important to write this construction because this construction will help us to divide this trapezium into a parallelogram and a triangle. Copy the figure for your reference. So ABCD is a parallelogram in which we have constructed a line CE parallel to AD. Now, so it has divided the trapezium into two parts. One is a parallelogram and one is a triangle. So ABCE is a parallelogram. Why it is a parallelogram? Because we have constructed a line CE parallel to AD. Okay, and we already know that AB is parallel to BC, which means AE will also be parallel to CD. So our coordinating image opposite sides, where the opposite sides are having this one parallelogram. And what is the property of the parallelogram? That if the sides are parallel, they are equal also. So DC will be 14, AE will also be 14, and CE will also be 15. Now, AD complete is given as 25 centimeter and AE we have found as 13 centimeter. So what is the measure of BE? It will become 12 centimeter. And again repeating, please listen it very carefully. What we have constructed CE parallel to AD, which is divided a trapezium into two parts. One is a parallelogram and one is a triangle. How this AECD became a parallelogram? Because by construction we have drawn AD parallel to PC and already AB is parallel to BC, which means AE will also be parallel to BC. So this becomes a AECD becomes a parallelogram. And in a parallelogram, opposite sides are also equal. So AD will be equal to EC. So both will be 15 centimeter. EC will be equal to AE, that will be 13 centimeter. And complete AD was given to us as 25. So AE will be 12 centimeter. Now triangle BCE, we have found all the three sides. Two sides are 15 and one side is 12. So you can apply Heron's formula to find its area. You already know how to apply Heron's formula. First we find the semi-perimeter and then we apply S minus A, S minus B, S minus C is the whole group. So S here comes out to be 21 and when we do Heron's formula, and I am quite sure that all of you have learned this method of finding the area using Heron's formula. So now this area comes out to be 18 root 21. Okay. Now, so what we will do is, now we will use the area of triangle, the formula half base into height to find the height of this triangle. So we will substitute the value of area of triangle to half base into height. We have to find the height of the triangle, so we will substitute the area by half base into height. So half base is here 12 centimeter, that is BE, into height. Now this will come out to be 6h and 6h will substitute to 18 root 21, so it will come out to be 3 root 21 centimeter. Clearly the height of the trapezium is the same as the height of the triangle. So we will substitute now the values in the formula of finding the area of a trapezium, half sum of parallel sides into height. So the answer will be 57 root 21 centimeter square. Let us see one more example of finding the area of a trapezium. A field is in the shape of a trapezium whose parallel sides are 25 meter and 10 meter. The non-parallel sides are 14 meter and 13 meter. Find the area of the field. So again here the height is not given, so we are going to use Heron's formula. So if you remember in the previous question we have constructed a parallel line to the side AD and divided into a parallelogram and a triangle. So here also we have drawn a line CE parallel to AD which divides it into a parallelogram, which means AD will be equal to EC, that will be 13 meters, and AE will be equal to DC, that means AE will be 10 meters, and AB here is 25, so AE is 10, so BE becomes equal to 15 meters. Here again I have pasted the figure for you to understand better. There is a parallelogram and a triangle, and we have found the measurements of AE, that is 10 meters, and BE is 15 meters. Again we will take the triangle BCE and find the area using Heron's formula. And Heron's formula, if you remember, all of you must remember this, that we will use first find the semi-perimeter. So semi-perimeter comes out to be 21, and when we substitute in the formula for Heron's formula, we get the area as 84 meters square. Now this area will be equal to half base into height. So base is BE into CL. So BE is 15 meters and CL we have to find, height is not given. So when we do mathematical calculations, we take the 2 there, it will become 168 divided by 15 or 56 upon 5. We have found the height of this trapezium. We can simply use the formula. Either we can use half a plus b into h. Here I have shown you another method so that you can use this method also. Area of triangle we have already found, and area of parallelogram, you know, it is base into height. So I have used another method of solving here, that instead of directly using the area of trapezium formula, you can use it as area of parallelogram plus area of triangle. So area of parallelogram is base into height, and height we have already found, so it comes out to be 112, and when we add area of parallelogram to triangle, we get the answer as 196 meters square. I have made a small quiz for you. So it is the overall recap of the entire chapter. There are only 6 questions and you are already aware about all the concepts. Area of equilateral triangle, you know it is root 3 by 4a square. You know Heron's formula. So I have made questions based on these only. Let us revise what we have discussed. In the entire chapter, we have learned about Heron's formula. Heron's formula is used to find the area of a triangle when the height is not given. If there are 2 steps, first we find the semi-perimeter, that is given by S, and then we find the area using Heron's formula under root of S, S minus A, S minus B, S minus C. And we have understood how to find the area of equilateral triangle. The formula is root 3 by 4a square. We have applied Heron's formula to find the area of a trapezium and a quadrilateral. Now, before you move on for your homework question, first of all, you have to see this presentation twice and solve these questions, and then only move on to the homework question. Homework question I have given you exercise 12.2 question number 3. In that question, it's a mixture of all the figures. There is a triangle also, there is a right triangle also, there is a rectangle also, there is a trapezium also. So if you have understood, you will divide this into different parts and then you will find the area. It is probably going to come in roots. You don't have to solve the roots. You have to just find the area of each part separately, and then in the last you have to write area of the figure is dash centimeter square. Okay, thank you.